The iPhone recently launched a handwriting calculator. I can create something similar using Python. Let's get started. Welcome to AOT, your go-to channel for all things coding. Today, we'll set up a handwriting recognition system using Python and Tesseract. So, open your browser and head over to github.com/ub_mannheim/tesseract/wiki. Download the Tesseract OCR for Windows 64-bit. Let's get it installed. Once downloaded, open your file manager and set up the Tesseract OCR. Now, here's a neat trick. Copy the destination folder path. Ready? Open your system settings and search for System Variables. Go to Environmental Variables. Scroll down to System Variables path. Click Edit and add a new entry. Paste that destination folder link. Hit OK, and you're all set. Fire up Visual Studio Code. Click on New File and name it calcuss.py. Save it in your Python folder. Next, we need to install a few packages to make this work. Open your terminal and type pip install OpenCV, then hit Enter. Next, pip install PyTesseract. And don't forget pip install sympy. Followed by pip install numpy. Once that's done, alright, let's dive into the code. Type along with me as we set up our handwriting recognition. We start by importing the necessary libraries: OpenCV for image processing, PyTesseract for OCR, sympy for math operations, and a couple of others for file handling and regex. Next, we initialize PyTesseract and point it to where Tesseract is installed on our system. We define a function to pre-process the image. First, we check if the image exists. If not, we throw an error. Next, we read the image. If we can't load it, we handle that too. Now comes the fun part. We convert the image to grayscale, apply Gaussian blur to reduce noise, and finally use adaptive thresholding to create a binary image. This makes it easier for Tesseract to read. Then, we create another function to recognize the handwriting. We call our pre-processing function here. If we successfully pre-process the image, we use Tesseract to convert it to a string of text, and we print the recognized equation. We also check if the recognized text contains valid numbers or operators, ensuring we only work with proper equations. Next, we define a function to solve the equation. If it has an equal sign, we treat it as an equation. Otherwise, we just evaluate it. We handle any potential errors gracefully.
The main function ties everything together. It processes the image, recognizes the handwriting, and solves the equation. Simple as that.
Finally, we set the path to our image and call the main function. Just make sure you replace the path with your actual image file. Press Windows plus R, type MS Paint, and in the Paint application, write 3 divided by 5. Save it in your Python folder as equation_image.png. Now, let's run the code again. And look at that. We see the recognized equation as 3 divided by 5, and the final result is 0.6000.